Okay, this is the review video for Unit 2, absolute value. So the main thing you need to understand about absolute value is that absolute value represents the distance between a number and 0 on the number line. So remember, when you're dealing with distance, distance has to be positive. So for instance, if I ask how far away is -5, what's the absolute value of -5 on, so the absolute value of -5 would be 5, because that's the distance from 0, 5. Okay, so if I take a look at the first problem, the main thing you need to remember about absolute value is that you have to isolate the bars. So for instance, these are your bars right here. So you can tell I still have a -5, so I need to move that. So +5 plus 5. So what I now have is I have the absolute value of 2x minus 6 equals 6. Okay, so I'm going to start splitting it. So some of your teachers may have used the analogy of jail. So right now 2x minus 6 is in jail. And once 2x minus 6 is free of the bars, okay, so no more bars, they have two choices. They could leave the bars and do good, so it has to be a positive number, or they could leave and they can do negative, so it has to be a negative number. And then from there we just start solving. So plus 6, 2x equals 12, and then x would equal 6. Over here I'm going to do plus 6. That gives me 2x equals 0, and x equals 0. Alright, on number 2, again, I'm trying to isolate the bars. Right now I have 3 times the absolute value of x plus 2, so I need to divide by 3. Divide by 3. That gives me the absolute value of x plus 2 equals 5. And again, I'm going to free x plus 2 from the bars. And when they're free, they can do good, which is positive, or they could do bad, which is negative. Okay, so if I keep working this out, I have x equals 3, and I also have x equals -7. So I have 2 answers that'll possibly work. Alright, on the next one, again, I got to isolate the bars. I got to get rid of this minus 6. That gives me the absolute value of x minus 4 equals 0. Now, 0 is neither negative or positive. So if you isolate the bars and equal 0, there's actually only going to be one solution, because I can't break it up into a positive 0 or negative 0. I only have 0. So if I add 4, I would have x equals 4. There's only one solution here. Alright, on number 4, it's already isolated. So I'm just going to start breaking it up right away. So x plus 2 equals 5. And x plus 2 equals -5. And it seems like it's very similar to question number 2. So I'm just going to start solving it. So x equals 3. And x equals -7. Alright, so these were all the equations, okay? So now, notice, all the equations have equal signs. Now I'm going to be dealing with inequalities, and they all have the inequality symbols, the less thans, greater thans, and all of those. Alright, the first thing you need to notice is you need to know what the sign is. So I know this is a less and. Now I'm not sure how your teacher taught it. This is how I showed my students. Again, just like with the equations, you have to make sure the bars are isolated. This is already isolated, so I can actually start solving it. So, just like with the equations, I'm going to get rid of that bar there. It kind of looks like a 1. Let me get rid of that. So just like with the equations, you can do good, so positive 3, or you could do bad and -3. So notice, the only thing I added were these 2 symbols. Okay, so now I'm going to do +1 on both sides. So my final answer is -2 is less than x, which is less than 4. Now, I can tell it's an open dot, so I'm going to put an open dot on -2, an open dot on 4, and I'm going to connect it. Now, it's really good to kind of know what the graph looks like before you solve it. So, for instance, if I know this is less than and it's going to look like this, you see how this is one piece? That means I'm going to solve this as one piece, okay? So, for instance, on this one, this is greater. That's greater. And remember, with greater, I know it's going to look something like this and something like that. So I've got two things going on. So that means when I solve this, I need to have two things going on. Now, this is already isolated, so I'm just going to start solving it. So I'm going to have 2x minus 3 is greater than or equal to 1, okay, which is pretty much the same thing I have here, just without the absolute value bars. Then I'm going to do the same thing over here with 2x minus 3, but I have to have the negative. So with the negative, I'm going to flip the sign. I'm going to have a negative 1, because again, you can do good or you can do bad. Okay, so on this one here, I'm just going to start solving it. So plus 3, that gives me 2x is greater than or equal to 4. Divide by 2, divide by 2. X is greater than or equal to 2. Over here again, I'm going to add 3, add 3. That gives me 2x is less than or equal to 2. Divide by 2, divide by 2. X is less than or equal to 1. Okay, so if I were to graph this, it's counting by 2's. Ugh. So here, I'm going to have a 2 here, closed dot going this way. The 1 would be, I guess, about right here. They're not touching. There's a little space in between there, and that would go there. Okay? All right, on the next one, I'm going to graph the equation. Now, the first thing you have to know when you're graphing the equation is you need to know where the vertex is. So this is your vertex. So these numbers here are what's going to tell me what my vertex is. So for my vertex here, even though that's a -1, because this is a minus, the h is really a positive, so 1. And then back here, what you see is what you get, so 3. So I'm going to put a point at 1, 3. Now, this is what I use to create my v. So this is -2 over 1. So I'm going to go down 2 over 1, down 2 over 1. And again, I can do it on both sides because I know it's symmetrical. And I can kind of keep doing that if I wanted to, going down 2 and over 1. And there it is. Also, if you'll notice, this is your axis of symmetry. You have x equals 1. Your domain, and I know they're only asking you to graph, but I figure I might as well tell you the rest of this. Your domain is always -infinity to infinity. Your range is a little trickier here. It's going to go down, so that means you're going to start off with -infinity because it's low to high, and the highest you go is 3. All right, so for the next one, it says find the solutions of the equation. So here I'm going to do, again, I'm going to isolate my bars, so plus 2. That gives me the absolute value of x minus 1 equals 4. Okay, I'm going to break x minus 1 out of jail, out of the bars. So when x minus 1 is free, he can do good or he can do bad. So I'm going to add 1. So x can equal 5. Or x can equal -3. All right, on this down here it says the water temperature in a certain production process should be 112 degrees. Now, depending on your teacher, they may have called this the target. If the actual temperature differs by 13 degrees, we call that our give or take. From the ideal temperature, then what are the maximum and minimum temperatures? Write the absolute value equation. Remember it says equation, so you have to have an equal sign that you can use to find the actual temperature. Okay, so we know we're doing absolute value, and I know I'm going to set it up like this. So I need to fill in numbers here. Now, the target always goes on the inside. And another way to think about it is if you do like biggie small, so the big number goes in here, and then the small number goes outside. Okay, so it's already isolated, so I'm just going to start solving it. I have x minus 112 equals 13, and I also have x minus 112 equals -13. So if I add 112, I'm going to have x equals 125. And then over here, if I do the same thing, I'm going to end up with x equals 99. So my minimum temperature would be 99, and then my maximum temperature would be 125. And then this is your equation right here. Okay, on the back, it says the temperature of a kiln should be 143 degrees. That's my target. That's your target. The product is defective if the actual temperature is more than 7 degrees away. So that's my give or take. Write an inequality, so this time an inequality, to represent the temperatures where the product would be defective and find the range of temperatures. Okay, so again, just like on the equation, I'm going to have x minus a number. This time it's an inequality. We're always going to use less than or equal to, and then another number. So again, big E small, or target's always on the inside, so 143 and 7. Now, it's already isolated, so now I'm going to actually start solving it. So when I solve this, I'm going to have x minus 143 is less than or equal to 7. But remember, when you're doing absolute value, you have your positive and you also have your negative. So now I'm going to add 143 to each side. Okay, so I have 136 is less than or equal to x, which is less than or equal to 150. So that's my range. That's my range. This is my inequality. All right, on this one here, it says use the graph below to describe the transformation and vertex. So on this one, I gotta find my vertex first. It looks to be located at -2 and -3, so that's my vertex. All right, so I think they want me, I guess I'm going to, this is for this whole problem. All right, so I'm going to describe the transformations. First of all, it reflected. So reflected across the x-axis. So remember, when I'm doing this, I'm comparing everything to that parent function, and this is what the parent function looks like. So I'm seeing how far everything moved from there. Okay, I can also tell that it moved left. So left 2, translated left 2, and then it also went down 3. So if I write the equation, I'm going to have y equals blank, and then x minus blank, and then another blank. Okay, so first of all, it reflected, so I know I have to have a negative there. The other thing is if I check the slope, it just went down 1 and over 1, so it's really just a 1 there. But I don't need to put the 1. I mean, it would look like that, but remember, you don't need the 1. All right, it did go left, so think of that as like a -2, and then it went down 3, so like a -3. So this would be like a template. So if I were to actually write my equation, it would look like this. You have y equals the negative. Here I have a negative and a negative. That's why it becomes a positive, even though it moved left, and then -3. So that's my equation. Now my vertex, this one does have a max because it flipped, and the vertex is -2, -3. All right, on number 12, you're filling in the table. So what I'm basically doing is I'm putting these and I'm putting them into the absolute value. So for instance, if I do the absolute value of -5 plus 2, -5 is 5 from 0, so 5 plus 2 is 7. Okay, here if I do the same thing, I put in the -2 plus 2. The absolute value of -2 is 2 plus 2 is 4. So now I have 7 and 4. If I do 0, the absolute value is 0, 0 plus 2 is 2. Absolute value of 1 plus 2 is 3. Absolute value of 2 plus 2 is 4. So just make sure, this is where people get confused with the negative. This is not negative 5 plus 2. It is not that. It is the absolute value of negative 5, which is 5. Okay, because it's all about the distance from 0. All right, on this one here, on number 13, the table of values can be modeled by which equation? So the best thing really to do here, y'all, is to just make sure you are putting everything in and it makes sense. So for instance, even if I start with the positives because I don't like the negatives, if I put 6 in here, 6 plus 5 is 11. The absolute value of 11 is 11. And that's not an 11, that's a 1. So it can't be that. Now here, if I put in the 6, 6 minus 5 is 1. The absolute value of 1 is 1. Okay, well that works pretty well. Okay, now I'm going to try a different number though. If I put in 1 here, 1 minus 5 is negative 4, and then the absolute value of negative 4 is 4. Well, that's a negative 4. So that can't be right. All right, this one here, again, if I put in the 6, the absolute value of 6 is 6, plus 5 is 11. Well, again, it's not 11, it's 1. Okay, so let's take a look at this one. This seems to be the right answer. Here I have 6. The absolute value of 6 is 6, minus 5 is 1. That's perfect. If I put the 1 in, absolute value of 1 minus 5 is negative 4. So that's your answer. All right, on number 14, it says if the absolute value of x minus 3 plus 1 is greater than 4, which of the following could be a value of x? Okay, well, if I put in negative 1, again, you could solve it. So if I put in negative 1 minus 3 plus 1, well, negative 1 minus 3 is negative 4. Absolute value of negative 4 is 4, plus 1 is 5. Well, 5 is greater than 4, so that actually works. So this one kind of works. Now this one here, though, if I put in 0, 0 minus 3 is negative 3. The absolute value is 3, plus 1 is 4. Well, is 4 greater than 4? No, it's or equal to it, so that can't be it. If I put in 1, 1 minus 3 is negative 2. The absolute value of that is 2, plus 1 is 3. Well, 3 is not greater than 4, so that can't be it. Same thing here, you have 3. 3 minus 3 is 0. The absolute value of 0 is 0, plus 1 is 1. And is 1 greater than 4? No. So the answer is A. All right, on number 15, it says use the graph below to fill in the parts A through G. All right, so on this one here, this is your vertex. So you have a vertex at 3, negative 2. I'm actually going to skip down here to the axis of symmetry. So the axis of symmetry is actually just this x part. And if you write it as an equation, it's x equals 3. Your x-intercepts are just where it crosses the x-axis. So that's 2. So x can equal, I guess I can write it as an ordered pair. So you have 2, 0, and you have 4, 0. All right, the domain, again, all day long is negative infinity is less than x, which is less than infinity. The range is your low to high. They want an interval. The lowest it goes is negative 2. And the highest it goes is infinity, because the arrows go up forever. All right, if I describe the transformations, I'm going to say that it went right 3, down 2. Now, if I check my slope, I'm going to rise 2, run 1. So that means my slope is actually 2. So this is a stretch, because it's greater than 1. So a stretch by a factor of 2. So if I come up here and write my equation, I'm going to have y equals 2. I don't put a negative because it didn't flip. Be careful here, it says right 3, so x minus 3, down 2, minus 2. Alright, on this one here, this is actually the parent function. So there's my vertex. So the equation for this is y equals the absolute value of x. Now this one here is where all the transformations are moved from. So when we're talking about like this one with all the transformations, how it moves from this 0, 0. So for instance, on the last problem, it moved 3 and down 2, so the vertex moved down here. Alright, your vertex here is 0, 0. The axis of symmetry is x equals 0. The x-intercept is 0, 0. All day long, your domain is going to be negative infinity is less than x, which is less than infinity, all day long. All right, your range, it gets low to high. They want an interval. The lowest it goes is 0, and the highest it goes is infinity. And again, this graph is symmetric with respect to the, so basically you want to look at where you can fold it and make it kind of flip. So if you fold it there, that's where it'll kind of like lay on top of itself. So it's symmetric with respect to the y-axis. Okay, I hope this helped you. If there's any mistakes, let me know, and I'll make sure I correct them, or if you have any questions. And that's about it. Good luck. Make sure you study.